Hello everyone, how's it going? It's been a while since I've done one of these videos, but I'm here now and we're going to get started on LeetCode question 1011, capacity to ship packages within D days. So you have a conveyor belt and it has packages that must be shipped from one port to another within days. The ith package on the conveyor belt has a weight of weights at I. Each day we load the ship with packages on the conveyor belt in the order given by weights. So this is a key indicator that we can't sort the input, and this is going to become important later. We may not load more weight than the maximum weight capacity of the ship. Return the least weight capacity of the ship. That will result in all the packages on the conveyor belt being shipped within days. Okay. They try to trick you with the example. It's given in sorted array, or it's sorted, but keep in mind that it has to be in the order given by weights. So in this example, you have 10 packages on the conveyor belt, and you have to ship them all in 5 days. So going through this example, our output is 15, which means the smallest capacity to ship all these packages within 5 days is 15. So the first day, if you add up all these weights, okay, you have 5 and 4, 9, 10, that's 15. That's within the capacity. This one is 13, 8, 9, and 10. So you get all these packages shipped out in 5 days without using any more weight than 15. Okay, and in this example, you see it's not in sorted order. We have to go through it in the order it's given. Ship all of these in 3 days. You can just look at the output as 6 and then kind of figure out these are all within 6 tons or whatever weight unit they're using, okay? So let's go and draw this up a little bit. One thing I need to point out is this is very similar to the problem Coco eating bananas. So you have some sort of time period and you need to kind of minimize or maximize something within the given time. Okay. So what do we know about this input, right? So what can we guarantee is some certain value or capacity that can get all of these shipped out within 3 days? Okay. So the maximum capacity would just be the sum of all of these numbers. So if you sum up all of these numbers, you're going to get 16. I've already done it before, so the sum of weights is going to be 16. And this guarantees that, okay, you know, in 1 day we can ship all of these out using 16. You know, it's never going to exceed that. So this isn't necessarily the answer. We still need to check for other values to see if it's less than 16, right? But what is the least amount? Like, just given this input, what do we think is the left boundary? So if the right boundary is 16, the left boundary would be the maximum value found in this array. So max at W, that's going to be 4, right? Let's say the number of days is 6 or something like that, and for each day you can ship out a container, and it's, you know, it's never going to exceed 4. It's always going to be shipped out that day. So these are some things you need to consider, right? Okay, so if we have these two values, we want to obviously minimize the capacity found and keep looking through the array and see if the capacity can ship out these containers within 3 days. So what we want to do is find the middle point of this left and right boundary. And if you couldn't tell already, this is a binary search type of problem. You have some sort of constraints and you want to search through a data structure and see if it follows some sort of rules. So mid, you're going to just add up these values and then divide by 2. So that's going to be 10, right? So we have our mid, and now we have to search through the list and see, okay, if we use a capacity of 10, is it able to ship out all of these containers within 3 days? And if the number of days we start at 0, so we can say D is equal to 0. If it ever exceeds 3 days, then that means it's just invalid, right? So let's say our capacity, and then we have our weight. So we're going to have our current weight as we're looking through the array. And we're also going to have our current capacity. Okay. So let's see if 10 is a valid candidate, right? So we're going to just say our capacity is 10, and we're looking at 3. So our current capacity is also going to be 10. And now we're looking at 3. Okay. So we know so far we can ship this container. If our current capacity is 10, obviously 3 is much less than 10. So far so good. And what we want to do is decrease the current capacity by that weight, because we have to search for other values. So we're going to do 10 minus 3. That's going to give us 7. So far so good. We're going to look at the next weight. So our next weight is 2. Okay, so 2 is within 7. So we're going to subtract 7 by 2. That's going to give us 5. We're going to look at the next weight in the list. That's 2. That's less than 5. So we're going to decrease this. 5 minus 2 is 3. Okay, and so far we're able to ship all of these containers in 1 day. But that doesn't tell us the whole story, right? So now we're going to move our weight up to 4. And this is interesting. So now our current capacity is 3, but the weight is 4, which is, obviously greater. So in this case, what we want to do is increase the current number of days to 1. The reason why is because we need to look for another set of containers that we can ship using this capacity. So after we decrease or increase our number of days to 1, we're going to reset our current capacity to whatever this is, which is 10. Okay? And after that, we're also going to decrease it by 4. So if we set this to 10 and then subtract 4, that's going to give us 6. Okay? So now this is day number 2. So this is 1, and now we're starting here at 2. Okay, now we're going to go over to 1. Obviously 1 is much less than 6, so we're just going to subtract this by 1. That gives us 5. And now we get to 4. 4 is less than 5, and we can decrease this if we want. It doesn't really matter. But this is going to be 1. So our number of days is 1, and that's less than 3. If we're using zero-based index, this is kind of what it means. We could also start at D equals 1 and say D is less than or equal to days. It doesn't really matter. The point being is this is valid, okay? Number of days is less than days. But that, like I said, isn't the whole story. We want to search for a potentially smaller capacity that also satisfies shipping all of these containers within days. Okay, and I think I can explain that better through code. Okay, so we're going to have our left and right boundaries, like I said. So the left boundary is going to be the maximum of weights, and our right boundary is going to be the sum of weights. So these are our left and right boundaries for binary search. And we're going to want to return smallest capacity. And I'm setting this equal to R for now because it's the maximum possible capacity, and we can decrease it if we need to. Okay. All right. We want to define a function that verifies if a capacity satisfies, all these conditions. So let's call it isValid. It's going to take capacity, and it's also going to take days. Let's just call it D. All right. So in this function, we're going to create some local variables. So one is current capacity, the other is number of days, and initially current capacity is capacity and number of days is 0. Okay? And what we want to do is look through, like I said, all of the containers, and that's going to be for weight and weights. Okay? And the first thing we want to check is if we need to increase number of days. So if current capacity minus the current weight is negative, less than 0, then this is when we want to increase the number of days, right? Remember when weight was 4 and current capacity was 3, that's when we increase our number of days. Okay, so number of days, and we're going to reset current capacity to capacity. And whether this is true or not, we want to decrease current capacity by the weight. All right. And finally, we want to return if number of days is less than D. All right. So given any capacity, this function is going to let us know whether it's valid or not. And this is where we actually do the binary search. So while left is less than or equal to R, we want to find our mid. So we're going to call it capacity. That's going to be the midpoint. Okay, so we got our capacity, and then we feed it to this function to see if it's valid or not. If it is valid, like in this case, capacity is 10, then we don't just return the answer. We want to see if it's less than smallest capacity. If it is, we update it, but we also want to look for smaller capacity, which means, you know, shifting the pointers. So if is valid capacity days, then we'll just take this much easier. This gets updated if necessary. Capacity. And then we're going to want to look for a potentially smaller one. So if we want to look for a smaller capacity, we need to move the right pointer one position less than the current mid or current capacity. So we're going to say right is equal to capacity minus 1. So look for smaller capacity. Else it's invalid, which means we need to increase our capacity. So this means moving the left pointer one more position past capacity, okay? And if everything looks good, we just need to return smallest capacity. Let's check this out. All right, test cases came through. Now let's submit it. And yeah, everything is good to go. So that's basically how to use binary search to solve this problem. It's a lot like Coco eating bananas, and I have a video on that actually if you want to look at it. But yeah, binary search is O of log n, and we're doing binary search on the entire input. So I think this would be O of n log n, but I'm not totally sure on that. But regardless, that's our solution. Simple binary search problem. Thanks for watching.